Welcome to this lesson on alkenes. Alkene is a hydrocarbon which is part of the organic compounds. I'll urge you to go back and then watch my first and second video on organic chemistry. Now, alkenes are double bond hydrocarbons. They form double bond, as well as they are unsaturated hydrocarbons. They are represented with the general formula CnH2n, where N represents the number of carbon atoms. One important thing I want you to note or take note of is that alkenes begin with ethene, not methane. Why? Let's look at the structure of an alkene. C double bond. You realize that one carbon cannot just exist without the other. One carbon cannot exist without the other. So you always have the alkene starting with 2 carbon atoms. So methane does not exist. Now you might be wondering, what is methane? I'll just do a recap. In the previous video, I mentioned that when the number of carbon is 1, the name begins with meth. So over here, before I write everything, I just want us to look at this and then see. So the name is meth. Yes, so the structure is going to be CH2. And I've explained that you can't have CH2 because if it's like this, it's going to be C double bond, then H here, and another H here, which is not complete. You need another one. So this does not exist. Methane does not exist. So it means we can continue with the others. N equals 2. When it's 2, we call it eth. N equals 3. We can call it, or the actual name is prop. When N is equal to 4, which is the number of carbon, is both. When N equals 5, it is pent. When N equals 6, it is hex. When N equals 7, I'll stop here, it is hept. So I'm going to write the structures formed, or the molecular formula for each of the alkenes. Looking at the formula, the second one is going to be C2H4, C3H6, C4H8. So these are the structures formed, applying the general formula. So the next thing, you are going to add the suffix of the family name. So ethene, propene, butene, pentene, hexene, heptene. One important thing I'll urge you to know about alkenes is that they can either form straight or branched chains. So they could either be like this, see. Now, why am I doing this? Now, in the previous video, I explained that the highest number of electrons around the carbon, or the carbon you have around it, is 4. Since carbon is tetravalent, it needs 4 more to be fully filled. So 1, 2, 3, 4. So when you add another one, it's going to be 5, which will make it wrong. So we have 1, 2, 3, 4 for this one too, for this carbon as well. So the carbon, as I said, could be a straight chain or a branch chain. So it's going to look like this, C, then like this, like that, like this, like that. We are going to talk more about this in isomerism in alkenes. Now let's look at some physical properties of alkenes. Which of them exist as in the gaseous state, and which of them exist in the liquid state, as well as the solid state. Alkenes, as I said, the first member of an alkene is ethene. So an alkene with carbon atoms from 2 to 4. So C2 to C4, meaning ethene to butene exist as gases, or they exist as gas. Then C5, that is pentene to C18. It means carbon, an alkene with 18 carbon atoms exists as liquid. Then from an alkene which has 19 carbon atoms exists as solid. So let's move straight to naming of alkenes. So since we said alkenes are organic compounds which are, so you know that they are unsaturated because they are double bonded. Yes, I spoke about that when I was talking about hydrocarbons. Now you realize that there's carbon here, there's carbon here, there's carbon here. Now when we say double bond, it doesn't mean that throughout the whole structure you have double bonds throughout. You just have a double bond at one part or one side. And you should be very careful when you're drawing the structure because there's a double bond here. So 1, 2 for this carbon. It means you have 1, 2. You need 4. So 3, 4. When you bring another one here, you're going to mess everything up. So this carbon also has 1, 2. You can add 1 here. 1, 2, 3, 4. Yes, 1, 2, 3, 4. When you add another one up here, you're messing it up. Then this carbon has only 1. So you can bring 1, 2, 3. Yes. So let's complete the structure. H, 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 H. Now I'd like to add another thing. Now this one is called a structural formula. Sometimes it can be written like this for you. Now this C has 2 H atoms around it, so it's going to be CH2. Then you have a double bond here, then CH, then CH3. This is called a molecular formula. Sometimes instead of drawing this one being drawn for you, this will be drawn for you, and this applies to alkenes. Yes. So how do you name this? This is the same as this. How do you name this? Now, one thing which is different from the alkenes is that with the alkenes, when you are naming, you state the position of the double bond. Now this double bond is found on the first carbon. The first carbon. So you are going to say 1, 2, 3. So the name is going to be prop 1 in. Since there are 3 carbon atoms, prop 1 in. Why 1? Because the double bond is found on the first carbon. So looking at the second question, it is given to us like this in the in the molecular formula. So we have to make it like the structure. So let's try to draw it. This C has H, 3 H around it. So H, H, and another H here. And this C, realize the H is in front of the C. But what you have to take note of is that the C is always at the center. So the H will be below or above. Then you have your double bond here. Then another C. So with this C is this C is here. Now after the double bond, this C. Now you realize that this one is in a bracket. What you need to know is that the alkyl group is always placed in a bracket. So once you see this, you know that it's an alkyl group. CH3. So once you see anything in a bracket, it's an alkyl group. Sorry, it's a substituent. Yes, substituents are placed in a bracket, not alkyl group. Any substituent, whether organic or inorganic. So we are done with this. So you realize that this C has 1, 2, 3, 4. This C also has 1, 2, 1, 2, 3. So this C now comes in. So this C has 1, 2, 3, 4. Then it has 1 H here. This 2, another H here. Then the last C with 3, 1, 2, 3. So H, H, H. So now we can name. Now to name, first of all, we look at the position of the double bond. Counting from here is going to be 1, 2. Counting from here is going to be 1, 2, 3. So 1, 2, and then 1, 2, 3. We go for the least number, so 2. So 1, 2, 3, 4, 5. So this is pent 2 in. Now, since we began counting from here, we maintain this position. So 1, 2, 3. The alkyl group is found on the third carbon, so it's going to be 3, methyl. Afterwards, you bring the name 3-methyl pent 2-ene. This structure looks very long, but we can simplify everything by drawing the structural formula. So this first one, the C has 3 hydrogen atoms. Then you have another C with a hydrogen atom, then double bond. So 1, 2, 3, 4. Then you have a C here. Now this C has an alkyl group, so CH3, or a substituent. Yes. Then you have another C here with your H. Then this CH3 is a substituent because it's in a bracket. Then you have another C, H here, another H here. Then this last one, C, H here, H here, H here. So to name this, let's count the number of carbon atoms. 1, 2, 3, 4, 5, 6. 6. And counting from here, 1, 2. The double bond is found on the second carbon. Counting from here, it's found on 1, 2, 3, 4. So we go for the least. 1, 2. So 2. So since you have 6 carbon atoms, it's going to be hex 2-ene. Some people call it 2-hexene. They are all right. So hex 2-ene. So from there, because we started counting from here, we maintain this order. So moving from left to right. So you have an alkyl group on the 1, 2, 3 on the third carbon, and an alkyl group on the fourth carbon. So the name is going to be 1, 2, 3. So 3, 4 di is methyl. So dimethyl. 3, 4 dimethyl. 1, 2, 3, 4, 5, 6. Hex 2-ene. Now before we move to our last question, let's try to answer this one. So with this question, you see we have 2 alkyl groups here, which are organic substituent, and then another inorganic substituent, which is chlorine, so chloro. So we have 1, 2, 3, 4, 5 carbon atoms. 5 carbon atoms. You have 1, 2. The double bond is found on the second carbon. So you know you have pent 2-ene. Pent 2-ene. Now, since we began counting from here, we maintain 1, 2, 3, 4, 5. Yes. So our first substituent is found on the second, and our second substituent is found on the third, which is the alkyl group. But what you need to know is that you name the inorganic substituent first before we name the organic one. So this is chlorine, and in naming we say chloro. And you know, because of the least number we wanted for the position of the double bond, we start counting from here, not here. The priority is the double bond, so it's like it's the highest in hierarchy. Yes. So we are going to call this 5-chloro. 5-chloro. Then we now come to the organic substituents. 5-chloro. 2,3. 2,3, meaning it's found on the second and the third. 2,3 dimethyl. 2,3 dimethyl pent 2-ene. Yes, so that is the correct answer. So looking at this question, we have the molecular formula, so we write the structure. C. So you have C, then you have 2 H atoms around it. So you must have Br somewhere here. Another C, another H, then with Cl, then C, and then H. You have the double bond here. Then you have C, and then H, then C, and then 1, 2, 3, H, H, H. So you have 2 inorganic substituents here. So to name this, we're going to look at first of all the position of the double bond. Counting from here is 1, 2, 3. It's on the third, but counting from here is 1, 2. So we start from here. 1, 2, 3, 4, 5. Now when you are naming the substituents, since bromine is a halogen, chlorine is also a halogen, you start with the alphabetical order. We use alphabetical order. B comes before C. So the name is going to be 1, 2, 3, 4, 5. So since it's 5, it's going to be pent 2. Why 2? Because the double bond is found on the second, which is the least. So pen 2 in. So starting, bromo is going to be first before chloro. So the position of bromine is 5. So 5 bromo, 4 chloro, pent 2 in. As I mentioned earlier, some people say 2 pentene. They are all correct. So properties of alkenes. First of all, we say that alkenes also undergo combustion reaction. So they undergo combustion reaction. Combustion reaction. You know, I can't talk about the combustion reaction without writing the chemical equation for it. So C2H4 plus oxygen, which helps combustion to take place to produce carbon dioxide, and then water. This equation is not balanced, so we introduce 3 here, introduce 2 here, introduce 2 here, and this is balanced. Now with limited supply of oxygen, instead of carbon dioxide being produced, carbon monoxide will be produced. Yes, so with the second point, alkenes undergo addition reaction. Now when we say addition reaction, there are different forms of addition reaction. So the first addition reaction I'll talk about is halogenation. Halogenation. And if you are conversant with the name halogen, halogenation shouldn't be something so abstract to you. It means the addition of halogen. So let's look at the structure of an alkene and see how halogen can be added. So this is an alkene plus a halogen, say Cl2, to produce C. So what happens is that anytime there's addition reaction, you have not all the time, but with halogenation you have an alkene, because the double bond is going to disappear, so you're going to have single bonds. So this is an addition reaction, that is halogenation. So the second addition reaction I'll talk about is hydrogenation. It means the addition of hydrogen. Hydrogenation. So example of alkane. So let's see ethene, C2H4 plus H2. So you have an alkane which is going to be produced. So we are going to have ethane, C2H6. Now this happens in the presence of a catalyst like nichrome. Sorry, nickel, not nichrome. Nickel, N-I-C-K-E-L. The final addition reaction is hydration. Hydration. To hydrate something. Hydration. Hydration definitely means addition of water. So this is an alkene plus water. Now, addition of water to alkene is hydration in the presence of concentrated sulfuric acid, H2SO4, or tetraoxysulfate 6 acid. You always have an alkane being produced, C2H5OH being produced. The last reaction I'll talk about, which is not under the addition reaction, is polymerization reaction. So it's the third. Polymerization. Polymerization. Alkenes have the ability to undergo self-addition to form a large molecule. Large molecules like plastics. So when you hear something like polyethylene means more ethene has been added to form polyethylene. So this is just a simple structure of the ethene and then polyethylene. So it means a continuous. This N here means more can be added. So polyethylene. That's why you realize that you don't have any atom at the end. It means it can continue on and on and on. So this is my this is the end of my lesson on alkenes. I'll urge you to subscribe to this channel, hit the notification bell if you've not done so, hit the like button, share as well, and keep your comments coming in. This is Sir Prince, and then keep studying by yourself. Thank you.